Oh, and we're live. All right, so this is Data Science Deployed. I am Jillian, and with me today I have my co-hosts Ben Cook and Donny Winston, and today we are going to talk about data versioning and all the reasons, why you would want to do that, and maybe some stories of what has gone wrong when you don't do it. And yeah, so who wants to get us started off? I think, Ben, you know quite a bit more about data versioning, definitely, than I do. I'm not so sure about Donny. He'll have to speak for himself.
Yeah, I don't definitely not an expert, but I do have a strong opinion that you should be versioning your data. I think, um, I guess just the main argument in my mind for why you should version your data is reproducibility. I think, in a lot of real world scenarios, your data set is dynamic, so it's going to change over time. You're going to add samples, you're going to fix errors, throw out outrageous outliers. Um, and there's probably a model you trained before you made those changes, and you want to be able to go back in time and recover that model result. Um, I think this is a good scientific practice. It's also just a good software engineering practice. I think you want to be able to replay in any model you are creating, and for that to be possible, you have to version your data set. And I think um, there's a host of ways you can do that. I think before the show, we were talking about a handful of hacky ways you can do it. I think there are good tools out there. Definitely, my favorite tool is DVC, open source project from Iterative. Um, it is tailor made for this, and it doesn't mean it's perfect, but I think it solves this problem really well. But I also think there are low fidelity ways to do this as well. The important thing is you really want to be able to go back in time and rerun your analysis or your model training or whatever. So yeah, basically you should version your data sets because that's how you achieve reproducibility. That's my sort of strong stake in the ground.
I agree with all that, Ben. I feel like people felt like this for software a little bit too, but maybe the tooling wasn't quite there. And so, like, I definitely remember, before I learned version control systems for software for text files, I'd have. Oh, I'm a little crackly. Yeah, I'll use headphones. Let me go to Jillian for a second. Why don't you take things over while I get a little more set up?
Okay, yes, so I will, take over this conversation as I do. So yeah, you were saying there are some more hacky ways to do that, and I was just thinking on that because actually I was digging into the DVC documentation this week, and I was also digging into another tool called Great Expectations, which creates this kind of like literate programming of your data set versionings as you go along, and I'm very into this idea of literate programming. So I was just kind of looking all into that. And one of the things that I saw when I was looking at DVC was that it was taking over kind of this process that previously I'd been doing manually, where I would throw in a git ignore for my data directory, and then I would have a make file that was syncing up and down between S3. And DVC does that, but they do a much nicer job. So I think I'm gonna, go switch on over to that, and then hopefully I'll have some real world advice on, how and why you should be using this. Of course, I do definitely agree with the whole idea of reproducibility and versioning your data and why you should be doing that. Previously, we'd been doing that a bit manually, kind of in any projects that I was on, usually with directories, data, v1, v2, v3, things like that, which, I mean, works if
It's
everybody's
not
being
horrible.
really, really
Like you can
careful.
get the job done with folders. It's just not the most elegant way to do it.
Yes, agreed. Elegant. That's the word
Yeah.
we should go for. I think we can all agree my make files are not elegant, but they're gonna stay around anyways.
Yep.
Yeah, and DVC has this nice comment in their docs. It says "make files done right," and I was like, "Oh, guys, you're calling me out here." So that was that. But all right, Donnie, why don't you bring us back to what you're talking about now that you have headphones?
Oh, sure, thank you. Um, yeah, I used to, save files with different file names or have folder structures or ad hoc ways of doing things. And then, I was told about version control, and I first was in a class and learned the SVN system, and then later on projects using Git, and it was just like, this is how we do things around here. And it was just really, really nice. I mean, it's whether it's intuitive or not is a different story, but there's lots of tooling around it. And it's just kind of a nice way of managing that. And I feel like with data, it's maybe taken a bit longer for there to be decent tooling around. It's like, yeah, sure, yeah, I want to version my data, but like, how do I do that other than the way I used to do so with code and files, where I like take a snapshot of something and like name it, v2, or name it with like a timestamp of my new thing, and then load that up and sort of manually do that versioning. And I feel like there are a lot of tools now that are recognizing that's really, really nice. And maybe it's because in part space is more cheap or less expensive, or it's easier to do kind of remote storage. And I think there have also been innovations in terms of structuring data to sort of reuse structure. Because I mean that's the big thing about Git is like, okay, let's imagine all of our stuff as like text, lines of text, so we can like produce efficient diffs as lines instead of having to restore the whole file again and again and again. And I think a lot of data versioning tools probably are doing similar things where they're kind of intelligently diffing. But also, even if they're fully storing the whole file, it's just storage is more cheap. It's network bandwidth is higher to kind of do streaming gzip and probably it's a lot of stuff like that. Yeah, and it's also interesting what Jillian was just saying about kind of the relating to existing tools that work well, that we know and have been around for a while, like Make, and relating them to that. I know before the show we talked recently about unfortunate incident that happened with data collection using Excel for COVID data, where they're using an older file format, and things didn't go so well. And I can just sort of see, I can tell that people, there may be better tools out there, but they're really used to Excel and they kind of know how it works a little bit, and they maybe know the limitations of it, but they like it. And I feel like, for me, a lot of times these like old Unix tools from the 70s are kind of like my Excel. They're kind of like, well, I sort of know these things and they work, and they're things that come every now and then, they're flash in the pan. Yeah, so but it's nice to see things that respect that tradition, but go beyond it. So yeah, I'm definitely interested in knowing a little bit more about what these newer tools are doing and the way that maybe Git did for code version control, because I know that Git, for example, isn't the right thing for data, in its native model. Data isn't usually, lines of text in files and easily diffable. They're kind of all over the place, tables, structured things. So yeah, maybe you said this a little bit while I was out, but maybe one of you, Ben, could go into a little bit more about the DVC like tool model as one example of this kind of thing that is hopefully going to bring us into the modern era of tooling for data versioning.
Yeah, definitely. I can talk about it a little bit. And I'm not an expert. It's still a relatively new tool for me. I'll say at Huddle, we use a tool called Quilt 3 to version our image data sets. And I think it was okay. I think basically it got the job done. I think as you both suggested, like there's more than one way to skin a cat here. But definitely, I think the tool I would recommend for people figuring out how do I want to version data sets is DVC. I think essentially I would think about it like Git for the sort of like machine learning part of the process, and versioning data sets is probably the core piece there. That the acronym DVC stands for data version control. And one of you really could think of it a little like Git LFS. So the sort of like large file add-on for Git. It's going to interact with different cloud vendors or networked file systems. in a consistent way. You get the same sort of like command line interface, regardless of whether you're using S3 or Google Cloud Storage or whatever. It does version those binary files or text files or whatever your data set is made of, and so you can make changes to it, and it'll only push the sort of like change in that folder or whatever. And it has some cool additional features, like if you want to reuse the same data set across multiple repos, you can sort of import a data set across from a previous project. So you don't need to store it twice. You can just reference data sets in different repositories. But what you actually version control is a pointer to that data set. So you get a sort of like reference to where it is and a hash so that you sort of like know whether it's changed or not. And then you get a tool to sort of like pull it down locally and then run your analysis. So I think, it's nothing super fancy, but it's actually very, very useful. And the idea is it can be really well integrated into your sort of like data science, machine learning workflow. And then like DVC has grown beyond just data set versioning. They've got a way to encode your whole DAG, your compute graph, and sort of only rerun steps where the dependencies or the outputs have changed. So yeah, I think it's a pretty interesting concept. I think one of the challenges is it's a little bit hard to learn quickly. I think that the basics are trivial, but then once you want to take it to a real world project, it is a little bit tricky to wrap your head around, which actually was true for me when I was learning Git, 7 or 8 years ago. So I think that is a challenge, and I don't know exactly how you solve that, but I do think the process is really important for building better, especially machine learning systems, which is what I understand. You have to have a solution to this problem, and I think DVC is a pretty good one.
Yeah, on the usability side, I don't know. I was looking at it and I was kind of thinking of that too, and referencing the Git issue that you just brought up, that Git is easy to get started with, but difficult to understand. So I'm hoping that, VS Code or, some of these IDEs and things take on sort of the DVC workflow, or maybe have like a plugin integration or something like that with the way that they have with Git. Because I do very little Git from the command line anymore. It's pretty much all like within my editor. I just don't really do stuff. But you both touched on really interesting points that I wanted to come back to. So one, Donny, when you were talking earlier, you were talking about like, well, how do we kind of, jump this hurdle between the software engineers or the more computationally focused data science and more like the end users, because this is data science deployed and we are all talking to scientists at some point. In particular, I'm talking to biotech people or bioinformatics or sometimes doctors who don't, have any kind of computational training. So, are there particular tool sets or systems that you guys like to sort of be like, okay, this is what we're using behind the scenes, but then this is kind of how we're going to translate it and present it to, end users, stakeholders, people who do not want to know about the code, maybe?
I'm in a project now, and we're trying to do data versioning, they like Excel. They like, they're used to that interface. And one thing we've developed for them is this idea of a change sheet, where you kind of in rows of Excel, what it does is it will map to changes in a document database, in a JSON database. But it will be a way for them to sort of type in things like, okay, on the document with this ID, this property I want to set to be this, and et cetera, et cetera. And so you have this list of changes, kind of like and you sort of give that like you'd give that to a waiter writing down your order, and then that thing gets run against the database to apply those things, and we also persist that change sheet, so there's a record of what was done. And so this allows people to not have to write database queries, but also gives us a record of what it is. So it's kind of a way of making it a little bit more accessible to people in a way where we didn't quite have the mental model yet to know exactly what kind of user interface we wanted, but we could sort of prototype that in a spreadsheet and do that. So I found kind of the spreadsheet based interface approach has been helpful for this sort of thing. And then the versioning strategy hasn't been ideal, but it's essentially been, okay, we have snapshots at regular intervals and we have these change sheets. So, you know, if we have, let's say we have a snapshot every month and we have a change sheet a day and we want to roll back to like the state of the database mid-month, we kind of need to go back to a snapshot and then apply the 15 change sheets, and then we can sort of get there. And yeah, so that's one way we're doing it, essentially to sort of connect with the scientists. They don't have to like learn database language. They don't have to learn, you know, in our case, you know, the MongoDB command syntax or query language or you know, JSON stuff. They can just learn this language for expressing in a spreadsheet what changes they want to make, and they're able to do that. I mean, we can have that change sheet just like it's almost like a human readable. It's something that the people generate that's analogous to a git diff essentially. You know, what do you want to do? And we're still playing around with that and the semantics and syntax of that. But that's one thing that I've gotten good feedback from. You know, definitely a couple people in the project have been like, I love change sheets. So that's been nice. Yeah.
Yeah, it's awesome that you've been able to go and, you know, like bridge that gap. I find that I don't that always makes people happiest, and it also helps the project to move along so much more smoothly when you can implement these kind of tool sets because, you know, everybody's happy and able to communicate and get changes, and you don't have just one person being the bottleneck. I'll have to ask you sometime about using like Excel as an interface because I've tried that a few times and it kind of blew up in my face, and I think it's probably because I wasn't able to like put constraints on the Excel because I wasn't really using it like a form. It was just a free text thing. I've done something very similar, or I do something very similar actually in quite a lot of my projects where essentially we use like a project management software, and I always use either Jira if people are already on Jira or Open Project if they're not, where we use the like they both have this kind of concept of having custom fields and forms and things like that. So anytime there's sort of a change request, it's like integrated into the project management software where they go and they open up a new issue or a task. And depending on the type of task, they get this like custom form. And then it can be pre-populated depending on, I mean, you know, essentially anything. I even, in a lot of projects, I have it hooked up with Apache Airflow, and, you know, it's like something else will kick off creating this task that then creates this change sheet, and it goes all the way down. But that's always interesting to hear of, you know, like other ways that people are dealing with that. Because I think that's really important to make sure that the other people in the project are also being included and that nobody's a bottleneck and all this kind of stuff. Do you guys ever use Superset for things like this? Because that's another.
No,
nope,
what's
nope.
Superset?
Superset is it's kind of like a dashboard technology, I guess. But what it does is that you can sort of give it arbitrary access to like any number of databases and query languages and even just like CSV files. Like you can actually upload a CSV file to the interface and you can create like different dashboards, all kinds of views and graphs and charts and things like that. But it is like a really quick way. If you have a database and you need to give people views into that database, you know, to get them started with that. And I mean, I've had a couple people that I've worked with. It's been kind of like their gateway into data science computing because they'll get started with that. And then they're like, this is cool. I can actually do stuff. And they'll start to learn a little bit of SQL because it has this really nice, you know, like autocomplete IDE. And it gives you so much stuff to start off with that, you know, then the scientists are able to get started and get their feet wet and then say like, okay, yeah, this is something that I could do. This is something that I could kind of take on, because it tends to be a lot of the time it's some very specific subset of knowledge. Like I'll work with like genetic counselors or something while they're creating like a new, you know, a new test case or something like that. So they know, I don't know anything about this stuff. They're the ones who know it. So we'll go set up those views in Superset and do things that way. So that's always been really interesting.
I really like Jillian, how you're connecting essentially versioning. I mean, what I'm seeing it as is connecting versioning with validation and interactive feedback. Because I mean, like I know on a code base, you know, versioning isn't so important if you're only going to have like one big version. You're kind of going to get it all done and then do it. But if you want to confidently, you know, make commits and push them up, you want to know that they sort of work right. And you know, the way I often have that with code is you know, with an IDE or test or some kind of visual feedback. You know, I'll often have like a linter or syntax highlighting or just things that let me know, like, okay, I think I'm on the right track here. And like, okay, yeah, I'm pretty confident about this. I'm running my tests. Okay, this is good. Now I'll actually like make a commit and push this as a new version. And then that's how versions happen. And that's how like a reasonable cadence of versions happen. And I think, you know, that same sort of thing I can see happening for data. You know, you need more than just the ability to cut versions, but give people the confidence to commit those versions. And so, yeah, like with these change sheets, like you mentioned with Excel, like you might get people putting in stuff, but they don't know if it's right or not. And so it's not like they're committing a version as much as they are emailing you and being like, I think this might be a new version. Can you take a look at this? Or like, it's not working for me. So they're not actually pushing the version. But you know, like for example, with my change sheet thing, you know, they can like upload it to a service that quickly validates it and says like, yep, this conforms to the schema. You didn't misspell anything, and they're like, okay, great. You know, I'm going to go ahead and submit that version. And what you're talking about is something probably even more intuitive, because it's not sort of submitting to something and getting a text, you know, response back, like all good. People can get multifaceted visual feedback on their data changes. That, you know, that they might go to the superset dashboard and they see like, oh yeah, all these changes I made to the data, like these make sense to me, you know, visually. And so I have some confidence that the underlying data, whatever it is, whatever the bits are on disk, you know, that this new version is going to be good. So I'll submit that. So yeah, I think for you know, to have sufficient velocity to warrant data versioning, because you're just cutting multiple confident data versions per day or whatever. I think validation goes hand in hand with versioning and being able to see the results of output. And I can imagine, yeah, like lots of tools in the ecosystem for validation and testing, like Great Expectations and just different just testing things and being able to work with data versions, and also just visualizing things really quickly, like superset, even in very generic ways. Being able to do exploratory data analysis on exploratory versions of your data. You know, like what happens if I change this in the data set? What does it look like? Oh no, that doesn't look good. Roll back. And I can see that being very powerful. This kind of, you know, versioning validation cycle, and these two things picking back to one another in the same way that I think a lot of you know, modern testing and IDE tools and linting tools help with code versioning, because people can confidently push versions. So I hadn't really thought about that before, but I think yeah, it's almost like validation and visualization is a huge part of confident versioning.
I think that's an interesting point about the IDE and the visual tools. And yeah, Jillian was mentioning that's how you work with Git. I have it on good authority that there's going to be a VS Code plugin for DVC pretty soon. And I think VS Code, like, it touches on a bigger point, which is like I used to use PyCharm, and I was hesitant to switch to VS Code, but it was just so much better for JavaScript. I was writing a little bit of JavaScript at the time, and I think today VS Code is better for Python than PyCharm is. Just the fact that it's open source, the sort of like ecosystem is expanding so much more quickly. And I think basically anyone wanting to write software today, like especially machine learning engineering, I just think VS Code is sort of like the correct place for that to happen. Yeah, there's so many good features. I think one in particular that I really, really like is remote containers. So you can do all your development inside a Docker container that is defined right in your project. And so you've got your environment version alongside all your other code. And that's helpful for installing packages and like dependencies, but it's also helpful if you need access to like a GPU. So you can, like the Docker container does not have to run on your local machine. It can run over SSH on a different machine. And all of a sudden you can run your debugger, linter, all your like, your sort of like normal VS Code tools from your laptop, but accessing a remote machine with a GPU it's really, really amazing workflow. And I think being able to version your data set directly in VS Code is just a huge win. I know they're working on tools for experiments as well. Yeah, so I definitely a huge fan of VS Code.
I'm still a PyCharm holdout.
You're still there,
you.
huh?
Yeah.
I was on the same path. I was on the same
But,
path where
I
I
mean,
used to use the PyCharm, and then I moved on over to VS Code. So I was just going to give the remote containers a +1 there. They are really great. I've been really digging into them lately too, and being able to, have my VS Code open up like in the container itself, and then do all my debugging and breakpoints and running tests and all that kind of stuff has just been great.
it definitely points to the importance and the effect of integrated tooling and ease of use, because like I have been doing similar things with using PyCharm and not just PyCharm, and I've done similar things in the past, related things in the past, just with Emacs, but things like that, like you kind of have to like get into it and kind of do a little bit of programming and do a little fishing around and bringing things together, and you can do it, and it's often the right thing. But for someone just doesn't know anything, to be able to like sort of click a button and install a plugin just to get going, get a feel for something, and then maybe later they want more customization, and so they use customization. They find like, oh, I don't have enough customization, so I want to go to another tool that allows me to do more customization. But that doesn't mean they shouldn't have started with the integrated solution. I think it's just great, lowering the barrier to accessibility for a lot of these things. It reminds me of a quote by, I think, Alfred North Whitehead. Like, civilization advances by the number of things we no longer have to think about, something like that. I'm paraphrasing. So I mean, just to like, I don't have to think about like development on a remote container anymore. I just don't have to think about it. I can think about other things. I think that kind of thing is really nice. So I definitely a nod to that.
I don't want to dump on PyCharm. I think PyCharm is a great tool, but I just think VS Code being open source is a strategic advantage. I think another example of that is Copilot. So obviously, like, kind of controversial, they're training on all of GitHub open source code. But it's a pretty amazing tool. I think it like feels very similar to the sort of sentence completion in Gmail or Google Docs. And I think VS Code being open source makes it possible for them to build on top of that and then expose it to beta users and those kinds of things. So yeah.
Yeah, and on the topic of open source, I think it's really nice that a lot of people have jumped on the bandwagon of open source in terms of a trust model. Like, another data versioning ecosystem tool that I've been playing around with for some projects is Terminus DB, and I know they were kind of very, very vocal at the beginning. I think they may have used a GPL license, but then they switched over to Apache 2, a more permissive license. And they were saying something like, yeah, you can't, we don't think that you can really release like a database today, or a data, something big like that people are going to really invest in without it being open source, because people want to know that they're not going to be locked in, and they need to really understand the internals of it. And I think that's great. That's I can talk a little bit about that. I'm no expert on Terminus DB, but just in terms of the data versioning space, I know kind of what they do is they'll focus on, not large blobs of files, but really structured data, like you'd find in tables or JSON documents, and they use this approach where they kind of decompose everything into this graph data structure, so that you can really take advantage of repetition in things across versions. So like if you have a JSON document that has 5 fields, and then you make a change to them, and one of the fields changes, they kind of have it in this triple format where you can just save that difference. And so it's a little bit more Git-like. It's almost like turning your JSON or table data into atomic statements analogous to the lines of text files in Git. And so you can really kind of get these fine-grained diffs of them. And I think that's the term they use. And they also have a lot of stuff that's like directly analogous to Git. They really want to piggyback off of that, the mental model that people have. Like they'll have commands like commit, and they'll have commit messages, and you'll do a rebase, and they'll do branching, and they'll so just like git branch, you'll have terminus db branch and terminus db rebase. And so I think they're really trying to go with that model and piggyback off of it. And I wonder if that'll be successful or not. But it's certainly a way to go where you kind of you see a lot of products that's like, okay, we're Uber for dogs or whatever. It's sort of like you take something that people know and you're like, okay, we're this. And I find that that's happening a lot with Git, which is nice. A lot of people are pushing and searching for quote unquote Git for data, which I think is a great place to start from, because a lot of people are used to that. But as Jillian said, also it could come from a completely different perspective if you're dealing with the different kinds of people who are using data. If you mostly have people who are in engineering who are already doing software version control and who are already familiar with Git, then okay, Git for data, great. But if you're dealing with people who are in the data world, managing data, and are used to managing data with Excel spreadsheets or whatever, and aren't used to doing Git day to day because they're not doing software development, they're doing data management. So it's like, okay, Git for data. It's like, oh, I got to learn Git first, or So I don't know, like what people think about that. Are there data versioning things that people have encountered that are not Git for data? They're specifically like, you don't know Git, we know you don't know Git, but here's an approach to versioning, or here's how we're packaging data versioning in a way that you might already be working with data.
Yeah, I think there are tools like that out there. Quilt 3, I was one I mentioned. It's not very popular. I'm not sure how the company's doing, but it definitely was a different. It was like it was built on top of S3's like built-in versioning system, and it was more like API sort of web-based approach. And I think weights and biases is similar. Like they will version your data set for you, but it's not like you're running a bunch of commands. I only have a vague understanding of both of those tools, but I think basically they're more API driven than sort of like a user at the terminal running commands to version the data set. That's my understanding.
Yeah, on my side, I work in these fields where we still very much have a human in the loop. So, for example, anything with clinical genomics that's medical data, I don't think even still legally you can have like just a computer, like just have these completely computer generated models and be like, yeah, sure, that's fine. Like it still has to be validated by a genetic counselor or in the lab or something like that. So pretty much all of my experience has been again, building these kind of interfaces on top of project management tools like Jira or Open Project. And then all the data versioning, it kind of gets abstracted anyways. And we're using the project management software like Jira, to sort of create like this audit trail of like, okay, so we have this gene and we want to add this, we want to demonstrate that this change in this gene creates this kind of like clinical effect is kind of a very common workflow. And, so then somebody will open up a ticket for that or an issue, depending on the software that you're using, and sort of have like that whole workflow. And it's like, it's very, very particular though to the data set that's saying this gene, this change in this gene, this clinical change, these papers have to be associated to it. You have to have this degree of confidence in like the raw data and all these kind of things. So that's really what I'm seeing on kind of the human in the loop side, where you have these very particular kind of use cases depending on the data set that you have. And then, again, you really need to have people on both sides. You need to have, you need to have the scientists who really know about the data, and then you need to have the software people who at least know enough about the data that they can go talk to the people who know more about the data and can, build these interfaces and things like that. And then, yeah, using the tools, like Superset and all this kind of stuff. I do think one really interesting kind of, development has been the whole data science community kind of coming together and really, basically insisting that everything be open source, and also that we're really starting to kind of converge upon the singularity, I think, in file types, where it used to be that, or maybe this was just a problem that we had in bioinformatics. Every time there was a new sequence, every time there was like a new analysis type, somebody would make up a completely custom file type for it. So for like, if you want to get your DNA sequenced, every step in that pipeline has a completely customized file type that is only used, like for that analysis type, for even that step in that analysis. And instead, in the last few years, I'm really seeing this kind of push towards, no, use these kind of more typical file types, use HDF5 that sort of encodes a, I don't want to say JSON type structure, but like almost that same kind of thing where you have keys and values, or use, like Parquet for CSV files, or now I'm seeing Xarray kind of come about quite strongly in the data science community. So even in the bioinformatics space, where I used to always think it was just a hobby of people to create new data types, instead of doing that, they're hooking on to using like Xarray or HDF5 or one of these. And my hope, anyways, I don't know if this is true or not, is that it's going to make it much easier for these data versioning tools if they have these kind of common APIs that they can sit on top of. Okay, we know this is a CSV or a JSON or an HDF5, that maybe then they can start to visualize like the different changes that are being made in the data. So if you come up with this kind of schema, you could sort of maybe have like some kind of interface that sits on top, that in the example that I just gave, if I say gene change in the gene clinical data, the clinical change or the clinical report or diagnosis or something like that, if that's encoded in your schema, maybe these tools like DVSC or Quilt or whatever will start to be kind of smart enough that they can just kind of infer, okay, this is the schema, so then this is the change that we're seeing, and then you don't even have to go build these custom data types or interfaces rather, because it's actually there within your schema. But I don't know, that's the dream. Are you guys seeing anything like this happening, or is it still all kind of new days?
Well, yeah, I think people are definitely getting sick of all the different file formats. One thing that I was thinking about that like has been an advantage for Git, or for kind of software version control is, I mean, Git, the tagline of Git is it's the stupid content tracker. I don't know if a lot of people know that, but the idea is that it's not smart. It's Linus Torvalds was very much like, this is stupid, and how it's stupid in a particular way, or the way that I'm thinking of for this discussion is, you might have lots of different files and formats, like Python, Ruby, C, different programming languages, or different configuration files like JSON, YAML, all sorts of different files. And to Git, it's just lines of text. Doesn't care. It's not smart. It's just lines of text. And so no matter what kind of file you're using, it can just version these lines of text as diffs. Whereas with data, we have all these different files. And so if you want to like version them and you kind of have to be smart about, how do I diff this data file? It might not be as simple as lines of text, or I can get a lot better because there's so much of it. And yeah, one thing would be to kind of have more or less one file format. The other thing would be to try and like treat it like Git, which a lot of people might do. And like, that's sort of, I guess, the Unix philosophy. A lot of people like that, a lot of these Unix tools basically deal with lines of text and streams. And so if we can make our files essentially lines of text, then like they're going to be great for Unix, and they're also going to be great for Git. Yeah, I wonder like what we can do in terms of either standardizing on the kind of more universal file formats for data, or just if there are fewer of them, then these version control tools, these data versioning tools, only essentially have to map to a few of these file formats. They can focus on them, and then we're sort of good. Because if you just have more and more file formats, then any data versioning tool is going to need to create a plugin for that file format or something. And whereas, Git, the stupid content tracker, kind of has an easier time of it. It's like, well, whatever your new programming language or configuration of file format is, if it's lines of text, then it's fine. We can handle versioning in a very, very, very silly way. Yeah, I don't know. I haven't found anything great for that. I know it's kind of the stance of a tool like Terminus DB is to sort of atomize everything down into these triple statements and to say okay, no matter if you're a relational database table or JSON, we can boil everything down to these subject predicate object statements, and those are sort of analogous to your lines in Git, and we can kind of diff those, but you still have to kind of map to that, and a lot of people are using that natively. So I don't know. It seems like a big problem because people are a little more clever with file formats than they are with code serialization. But I mean, you have trouble with code because you want to know if the code's valid, and the way you do that is you don't do that in your versioning system, right? You kind of have separate tests that you have to run to know that this code file is actually valid. Like you need to run a linter or test against it. Git doesn't know that it's valid or not, but we need to know that things are valid, and so we write tests. But the tests can get out of date, and it's silly. And I definitely see a corresponding thing with data where things might be able to be smarter. Where for a given data format, the versioner could maybe know about the schema of the data too, and can not check something in unless it conforms to that. And it might be a little bit more atomic because it's about the formatting of the data, and it's a little bit more well scoped than about code, where it could be some long end-to-end integration test or something. I don't know. I'm wondering if people have had experience with that, versioning not just the data, but also I guess the metadata or the schema, and versioning schema changes. That's maybe a related thing, because you'll have data versions, but you may, if you're rolling back to a given data version, you also want to roll back to the schema, right? And with code, it's all one thing. When you roll back to that version of the code base, you also roll back to those versions of the tests. But yeah, I'm wondering what kinds of things have you seen in terms of schema versioning, these kind of coordinated, correlated versions? Yeah.
I haven't seen much of that, to be honest. I've worked with JSON schemas a little bit, but really mostly I don't think that much about schemas as something distinct from the data or the code.
I always used to deal with this in kind of what I call my stupid people test fashion, where I would have a wrapper. So instead of using, I don't know, let's take pandas for an example. So pandas read CSV, right? Sort of the generic read CSV. I would create a wrapper around that had a bunch of assert statements in it. And if the assert statements failed, I would be like, well, something has gone wrong somewhere. I was having a look at this library called Great Expectations, for a new project that I might be taking on. And I think this probably does a lot of that, but in a much smarter, more automatic way, where it can just infer a bunch of stuff essentially about your data, about your schema, about kind of the allowed values, just and it just creates this whole bunch of metadata, and then you can put more specific metadata in there. And then one thing that I like about that too is that it creates this HTML report out of that. And because you can customize that, again, we're back to this kind of idea of having people in the loop, and then having something that you can present to the other people that you're working with, either the other people on the team or scientists, but you get something you get an artifact out of that that's very readable, which I think is very important, because I like having all these automated tools that are considerably smarter than I am, but at the end of the day, I want something that I can actually read and that the people that I work with can actually read too. So yeah, I don't know. I think it's a problem that's still going on. I wonder if, maybe the file types are going to kind of move in this direction that I've been seeing like web APIs take. I don't know if you guys have noticed that, where it seems like so many tools are going on this open API spec. So for example, this tool that I use called Open Project, that I use for a lot of this kind of auditing and validation and creating these different workflows for people, they just adopted the Open API spec, which I am so psyched about. And you're seeing more and more of these tools like, yeah, using these different specs, and then you can actually just generate libraries, because if everybody's using the same spec, it can like inspect the spec, I guess. That's a terrible way of putting it, but we'll just go with that. And then create different libraries. So, I think Kubernetes does this too, where they have their open API and then they're creating like all of these different, other different SDKs. So you can have the Kubernetes library in, Python, or I don't know what other languages, because I only really pay attention to Python. But so say you can have it in Python, and it's the same thing as using, like the Kubernetes on the command line. It's just they're calling it from Python, but it's calling all the same functions. So I'm wondering if we're going to all just kind of approach, if maybe the pendulum is just kind of swinging in that direction, and then everybody gets sick of it, and then it swings back, But I don't know. I mean, I'm still just kind of watching and waiting, and I think it's a very interesting space. And I did, I guess we're going on time, but before we took off, I did kind of want to say, I also think these tools are important for anybody in the data science space, because you really want to make sure, of course, not only that you're doing a good job on, like the projects that you're on and fulfilling them to the best of your ability, but there is also, this kind of question of like, well, how much responsibility do you have if data is lost, if data is, corrupted, if something like this goes wrong? It seems like when something really does go wrong, like before the show started, we were talking about the company that, lost a bunch of COVID data, and that's pretty easily looked up if anybody wants to look that up. And not even to say like, I'm bragging on this poor data science team, because you just know those guys were like sleeping under their desk, and somebody was, like, get this out faster, and everybody was probably very stressed out, and it was kind of a difficult situation for all. But I mean, one of the questions that came out of that I followed really closely was, well, whose responsibility is it? Is it somebody's responsibility? Because this was, presumably somebody paid money. This was real data. I think they were supposed to be doing contact tracing out of this. Maybe there were people, that had been in contact with somebody who had COVID and weren't notified because this data became lost. All these kind of things. It certainly made me become a lot more careful about the kind of contracts, because I'm independent, and things that I will take on for myself, and that, my kind of policy is now, unless I have, these kind of things written into the contract, I'm not going to take it. And specifically, because it does take more time, it is more effort, and is therefore more money as well, too. I will only take on projects where they are willing to kind of invest up front on, this kind of, I don't want to say data engineering platform, because I feel like that sounds too high in the sky, but at least, like something like some kind of auditing, some kind of, control, making sure we're backing up at least an original data set someplace that sits somewhere that nobody can touch, like at least to do something reasonable. What are your guys' thoughts on that before we head out for the day?
I think that's fantastic. I think it points to versioning and the value of versioning, because I think, people would love to have these alarm bells going off, like, hey, something's wrong here. But how actionable is that nowadays for a lot of people? Like, if you get an alert like your data's messed up, like, okay, I've got to like go look into it and like, maybe reconstruct it and run the things and like trying to get it back to a good state. And maybe I'll just take the site down, or I'll tell people to not use the data for a while we figure it out. But if you have versioning, if you have this way of doing rollback that's actionable, then these alarm bells become more valuable, because it's like, okay, if I set it off alarm bells that something's wrong, the first thing I can do is roll back to the state that wasn't producing alarm bells, and then go into it. Then and I think a lot of people are reticent to like have these testing alarm bells things, that because, well, what can I do about it if something goes wrong? It's going to be a week of work. But if you have versioning and the rollback that goes well with it, then I think you're probably more likely to want to do this like testing and alarm bells, because there's something you can do about it. You have something to roll back to. So I think that's great, and I think effective versioning can kind of help with data quality issues because of that.
Yeah, I think they're best practices. I think version your data set, back it up somewhere that's not your laptop. But I also think that, no system is perfect and mistakes are going to happen. So I feel for that team that lost that data. It makes me want to work with data that's less sensitive than COVID numbers. I think there's they're humans in the loop, and mistakes are going to happen. So I just think some of that is unavoidable, and you minimize the impact of that. You limit the mistakes that are going to happen by following best practices.
Cool. All right. Anybody have any kind of final thoughts for the day?
No.
Nope. All right. Well, okay. That's the end of the show. Thanks, guys, for coming on, and it was fun as always. And we'll talk about something else next week.
Very fun. Thanks to both of you.
Yep. Thanks, guys.
Bye.
Bye-bye.
Bye.